Hello. If you are watching this video right now, it's because you're either needing a refresher on polar graphing and polar coordinates, or you've never seen it before and you would like to learn a little bit more before you have to experience in a BC calculus class. So first of all, let's talk about right triangle trig, which is this coordinate conversion right here. We know that the tangent of an angle is opposite over hypotenuse, or excuse me, opposite over adjacent, and the cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. And in this case, we're using the length r as the length of the hypotenuse. And pole is polar speak for the origin. So you'll hear me use pole instead of origin sometimes. Now, rectangular coordinates are what you're most familiar with. And the reason for that is when we look at the ordered pair xy, we go left or right x and up or down y. And what that makes is a rectangle with the x and y axis. So that's why that is called rectangular coordinates. Polar coordinates will get you to this same point, but rather than going the perpendicular distances to the axes, you're actually rotating an angle and then going out a distance. It's almost like a vector. It has direction and magnitude. So your magnitude would be r and your direction would be theta. And you can still get to the same point. Hopefully that makes sense and we can kind of go from there. So we're all more comfortable with rectangular coordinates. It's just that's what we learned how to graph with, and so that's going to be our fallback every time. But here are our coordinate conversions that you're going to need to know whether you're going from polar to rectangular or rectangular to polar. Where are we getting that the length of x is r cosine theta? Well, we get that if you go up here and you cross multiply. X times 1 equals r times cosine theta. Likewise, we can get to y equals r sine theta from our rectangular coordinates and right triangle trig. So you're going to need to know that in calculus to be able to make some conversions for some things that we do. Going the other direction, if you know a polar coordinate in terms of r, the distance from the pole, and theta, the direction that you're going, then we know that the tangent of theta is y over x. Again, that's just straight up opposite over adjacent. And then this r squared equals x squared plus y squared is just coming from the Pythagorean theorem, where a squared plus b squared equals c squared, but we're dealing with the lengths of the sides of the triangle to be x and y and the hypotenuse to be r. So let's talk a little bit and use an example here. For the point 2 comma theta, x equals 2 times the cosine of theta, and the cosine of theta is -1. So that point, the x coordinate would be -2. And then over here, y equals r times the sine of theta, so 2 times the sine of theta, and the sine of pi is 0, so we've got the point -2, 0. And I think you can see that if you rotate pi, which would be here, and you go a distance of 2, that would put you in rectangular form at the point -2, 0. You get to the same point, you just get to it in a different manner, okay? And then they're showing a second example with r being √3 and theta being pi 6. You've got to be a little versed with your unit circle trig to be able to get to that. But again, √3 times the cosine of pi 6 and √3 times the sine of pi 6 gives you this point right here at 3/2 square root of 3, 2. But if you looked at that in polar, the distance here would be √3 and the angle would be pi 6. Again, we're going to use radians more than degrees just because in calculus we use radians more than degrees. Going the other direction, if you have the point -1, 1. So here we are, xy, -1, 1. What is this distance and what is this angle? So we need to find out, first of all, that the tangent of theta is y over x, so that gives us -1. And then we can look at that. Where is tangent 1? That's at the pi fourths, but in the second quadrant, that would be 3 pi fourths. And then using the Pythagorean theorem, you get that that distance is √2. So in polar form, that point would be √2, comma, 3 pi over 4. Okay? Now, interesting thing about polar coordinates that is not true in rectangular. In rectangular, there is only one way to express the point -1, 1. You just go left 1 and up 1. But in polar form, there are an infinite number of ways to get to this point. Maybe not as efficient as √2, comma, 3 pi over 4, but let's think about it like this. Could we get to that point by rotating around 2 pi plus 3 pi over 4? Yeah, we could. So another way to express it, if we add 2 pi, which would be 8 pi over 4, is 11 pi over 4. Could we get to this point by going in a negative direction? Sure. So we would still have square root of 2, but the negative of that would be what? -5 pi over 4, I think. Notice that in every case here, my r is positive, and you would think that that's the only way to express a radius. We don't think about a radius as ever being negative. But in polar form, what if, let's say we went, I'm going to extend this down, let's say we went negative pi fourths. So that's our theta. How do we get, so we're pointed right here, the way to get backwards. And so when your r is positive, I always think that I'm moving forward. If my r is negative, I'm pointed toward negative pi fourths. But if I walked backwards, I would get to the point that I want. So basically, I'm pointed in this direction. However, I walk backwards and I get to my same point. So again, I could go around the unit circle multiple times and get to the same point. So it's kind of cool. Not that you're really going to need it, but I wanted you to see all of that. Okay, so this first little worksheet that I'm going to just play around with you a little bit, but I want you to complete it, is let's talk about going from r to theta to xy. Remember, x is r cosine theta, and they're using degrees, so I guess we'll use degrees, and y equals 4 times the sine of 90. Remember that the cosine of 90 is 0, so 4 times 0 is 0, and the sine of 90 is 1, so 4 times 1 is 4. So my answer here would be the coordinates 0, 4. And you can check that. If you were to rotate 90 degrees and go forwards 4, wouldn't you be at the point 0, 4? Okay? Let's look at maybe another one. What about the r of 0 and an angle of -210? Well, if we're going to multiply by 0, it really doesn't matter what the angle is. We are staying at the pole. Okay? Going the other direction, the point 1, 1. And it may be helpful for you to kind of think about this draw it out. So the point 1, 1 is in the first quadrant. So 1, 1. And so theta equals the inverse tan of 1 over 1, which is 1, and the inverse tan of 1 is pi fourths. And again, the Pythagorean theorem, 1 squared plus 1 squared is 2, and so theta would, or r would be root 2. So root 2 comma pi fourths, and that's the most efficient way to get there. Again, there are an infinite number of correct answers to express the 0.11 in rectangular into polar form. Some of these you may need a calculator for. I'm okay if you leave it as inverse tan, or maybe not. Maybe it would probably be best. So let's look at the point -3, 4. Again, I think it makes sense for us to get what quadrant we're in. So here's -3, 4. And let's talk about theta and r. R is pretty easy. This is a 3, 4, 5 triangle. So let's just go right into the point 5 comma. But theta, if I do the inverse tan of -4/3, that is going to put me in the 4th quadrant. And my answer, if you put that in the calculator, it's going to give you a 4th quadrant answer. So what I would like to see you do is think this through. The reference angle is equal to the inverse tan of opposite over adjacent. And notice that I'm taking the sign out, the negative. So 4 over 3 would give me the 1st quadrant answer. The 2nd quadrant answer then would be pi minus the inverse tan of 4/3. And if you wanted to leave it like that, I would be fine with that. Again, infinite number of ways to express it. Now, when we talk about going from rectangular to polar and polar to rectangular, as far as an equation, that gets a little bit sticky. Some of those are more difficult than others. Let me kind of walk you through all of these. Remember from up above, x squared plus y squared is r squared. So anytime I have that combination, I can say r squared equals 4, and so r would equal 2. You could say plus or minus 2, but really it's going to give you the very same thing. And here's the deal. X squared plus y squared equals 4. You know what that is. It is a circle of radius 2. Aha, radius 2 right there. Now, remember when you only have one, like if you have x equals 5, theta can, or r, y can be anything. If you have r equals 2, theta can be anything. So see where I'm going here? Theta can be anything. Positive, negative, going around infinite number of times, but r is always 2. How about that? Y equals 4. What do we do with that? Well, we replace y with r sine theta. So r sine theta equals 4. Now, if I put this in the form that these come in, so you write them, you know, r in terms of theta. Usually we write functions y in terms of x. These are r in terms of theta. So 4 divided by the sine of theta. And you know that the inverse, the reciprocal of sine is cosecant. So this is 4 cosecant theta. Okay, x equals 10, you would do the very same thing with r cosine theta. So you would get r equals 10 divided by cosine, and r equals 10 secant theta. R equals 3. Well, let's square it. So r squared equals 9. And then remember what we did up there on number 8. We replaced the x squared plus y squared with r squared. Now we're going to replace the r squared with x squared plus y squared. So that one's pretty easy. And then these are very, very similar to what you had up above. R sine theta equals 4. So we could say y equals 4. And those are just lines. Crazy ways to get a line, but you can still get anything in polar form and rectangular form. Usually one way is easier than the other. Here r equals -2 secant theta. Remember, like what I did up above, r equals -2. Let's put it over cosine, okay, and then cross multiply, and we get r cosine theta equals -2, so x equals -2. Now, down here is if you were taking advanced pre-calc, you would have to be able to look at a graph in polar form and know what the polar form is, and then possibly give somebody the rectangular form also. That's not going to be as important in BC. BC, it's going to be more plotting versus memorizing, and maybe that will be easier for you, but I did want to give you a little bit of a feel here of what's going on. 14 appears to be a circle. It appears to be a circle with center at 3, 0, and a radius also of 3. So if we write this in rectangular form, we would get x minus 3 squared plus y squared equals 9. So that's our rectangular equation. But what would our polar equation be? Well, let's see here. You would expand this and get x squared minus 6x plus 9 plus y squared equals 9. Okay, our 9's are going to cancel. Our x squared plus y squared we can replace with an r squared. Our 6x can be 6, and remember x is r cosine theta. So we're kind of getting somewhere here. We've got x squared plus y squared. And so it looks like to me we've probably got something like r squared equals 6r cosine theta. And it's very bad to ever divide by a variable, because the variable could be 0. But I think we can see from this picture that our variable r is 3, so we're not dividing by 0. So it's okay to end up with r equals 6 cosine theta. And that would be the way to grind that out. But again, that is not as important as being able to just plot it. And what do I mean by plot it? Well, let's look at it. Where you're used to doing a t-chart with x and y, we're going to do a t-chart with, let's put in theta and solve for r. And usually I would say, let's just put in some values. So 0, maybe pi fourths, things that are easy to work with, okay? Pi halves, 3 pi fourths, and pi. And let's see what we get with that. So remember, we're plugging into this equation 6 cosine theta. So the cosine of 0 is 1 times 6 is 6. So there's that point. Okay. The cosine of pi fourths is root 2 over 2. So times 6 would give us 3 root 2. And I'm not really sure what that is. That's going to be maybe about 4.5. So let's see, I'm pointed toward, we'll kind of bisected here. And so a little bit more than 4. Yeah, I like that point right there. That'll work. Pi over 2, the cosine of pi over 2 is 0 times 6 is 0. So now we're here. 3 pi over 4. Okay, the cosine of that is negative. And so here's something really cool. I'm going to write a -3 root 2 here. So remember, I'm pointed toward 3 pi over 4. I'm in the second quadrant, but my r tells me to go backwards. And so there I am, right about there. I'm going to say that's pretty close. So remember, I'm pointed this way, but my r is negative, so I go my distance in the opposite direction. And then pi gives me, cosine of pi is -1, so -6. So I'm doing the very same thing. I am pointed toward pi, But instead of going 6 in that direction, I go 6 in the opposite direction. And look, I made my circle. Isn't that cool? I know that it's more efficient and more intuitive to do it in rectangular form, but you can do it either way. Here are some really crazy ones. This first one is called a Limison. It has a loop. And let's see, I should know what the equation of this is. Let's see, it looks like our loop is 2 and this is 8. So this is the equation R equals, I think, let's see, 8 plus 2 cosine theta. No, it's 2 plus 8. My bad. I changed my mind. 2 plus 6. We're going to get there, I promise. Okay, so here we go. Again, if you were taking advanced pre-calc, you would have gotten that faster than I just did. So let's do the T-chart. I want you to see, again, this is what you're going to have to do in BC second semester. So theta, R, and this time I'm going to choose a little bit easier points. I'm going to use 0, and I'm just going to go up here to pi halves, pi, 3 pi halves, and 2 pi. And let's see what I can get out of this. The cosine of 0 again is 1, so 2 plus 6 is 8, and there's my first point. The point 0 pointed toward 0, radians or degrees, and out 8. Pi halves, the cosine of pi halves is 0, and then I need to get 3 there. How am I going to get 3 if I don't make this 3? That should be... All right. I am not doing so hot, am I? 8, and this is 3, and this is 3. So this should be 3 and 5. I know that that needs to add up to 8. Okay, so that's going to give us 3. Pi is going to give us... Oh, here we go. Now I've got it right. Sorry, gang. Okay, I'm pointed toward pi. The cosine of pi is -1, and 3 minus 5 is -2. So there's that 2. Remember, I'm pointed toward pi, and I go backwards 2. So that gives me that point. 3 pi over 2, again, is 0. I'm pointed in this direction. I go in that direction 3. So there's that third point. And then 2 pi is going to take me back home to 8. Sorry for that little blip in my brain. Now, where is that loop happening? This is kind of something else that you may have to figure out for me. Where is this happening? You can see that you actually do cross the pole. And when you cross the pole, R is 0. So 3 plus 5 cosine theta equals 0. The cosine of theta equals -3/5. And so if you would do an inverse tan of that, of 3/5, you would get a first quadrant reference angle. And so to get this point, it would happen somewhere in here in the second quadrant. And you know in the second quadrant cosine is negative. It would happen again in the third quadrant where cosine is negative. So these answers would be, we would get R equals 0 for pi minus the inverse cosine of 3/5 and pi plus the inverse cosine of 3/5. Okay? Petals. Petals are one other thing that we're going to talk about. This is, again, things that you would have to memorize. If you have something in the form of R equals some constant in front, let's just say B cosine or sine of theta, without the something added or subtracted to it, you would get one of these that looks like petals. If there is a coefficient in front of theta that's even, you get double the amount of petals. If it is odd, you get the same amount of petals. I know that sounds crazy. It looks like here my R is 7. So this would be R equals 7 times the sine of 5 theta. This one over here, I see an even number of petals. Looks like my radius is 6. So R equals 6 times the cosine of 2 theta. So let's kind of go back that again. This is the petal length, this 6 and 7 respectively. How did I know this one was 5? I counted 5 petals, and odd always has the same number of petals. Even has double, so since I had 4, this had to be 2. How did I know the difference between cosine and sine? I know that cosine starts its first petal symmetric about the theta equals 0, and I know that sine is off of that. So that's kind of how I knew that. You're not going to have to know that. So let's talk about how to get a petal. That's all I'm going to need you to do in BC. So let's go theta and R. And up here, when I went through this, notice that I just hit 0, pi halves, pi, 3 pi halves, and 2 pi, because my coefficient in front of theta was 1. When my coefficient changes, I'm going to adjust it. So this one, I'm going to go through and divide by 2, because this is 2. Up here, I would divide by 5. So I'm going to start again at 0. And instead of pi halves, I'm going to go pi fourths. And then I'm going to, now I've committed to go by pi fourths. So this is pi halves, 3 pi fourths, and pi. And I guarantee you we've already gone too many to just to get one petal. So the cosine of 0 again is 1 times 6 is 6. So there's that first point. Pi fourths times 2 is pi halves, so there's 0. So look, I have already traced half the petal. Now, am I going to trace the other half? No, I don't think I am. So this is weird. It doesn't draw it like you and I would draw it. So cosine of pi halves times 2 is pi. So here I'm going to get -6. So when I'm faced this way, I'm down here. So it looks like my path looks like this. See where? So I've kind of graphed 2 halves of 2 different petals, not of the same petal. 3 pi fourths is going to take me back to 0. So there I have finished a petal. Now here's where things are going to get dicey next year, and then I'm going to need you to kind of understand. If all I want to do is figure out how to get around this petal without going through all the other petals, I kind of have to think backwards. So because this started at 0 degrees 6 and went to the pole, I have to think, what's going to give me this bottom half? So what if I go from negative pi fourths to positive pi fourths? Will I get that petal? And I think you're going to see that we will. Negative pi fourths, and then we're going to come around here and start up here. So that's the cosine of negative pi over 2. So negative pi over 2 is down here. And we get 0. So we're here. And then at 0, we're 6. And then at pi halves, we're back to 0. So this is how you would get the first petal, or just one petal. Okay? Lots more to look at here. I guess I just want you to kind of think about this. Oh, that one's pretty. That would be fun to draw. And where I'm going to take you next is kind of your homework. So when you have finished this and you have questions, I want you to let me know. This is kind of what I really want you to be able to do. Plot the point with the given polar coordinates. So if we would go 3 pi over 4, we would be right, pointed in this direction, but going in the negative direction puts us this way with a length of 1. So there is that point. So all you're doing on this is just practicing graphing a point in polar form. And that's what all of these look like. Okay. Now find all pairs of polar coordinates that describe the same point. That's going to be, dealing with adding 2 pi or subtracting 2 pi. And I'm not as concerned with you being able to do this. You're going to have at the end of this all of the answers, but I'm going to say don't worry about these. Okay? Now, convert each pair of polar coordinates to rectangular. Yes, I need you to do that. So let's just take a look at one of these. Let's come over here with 9. X equals 4 times the cosine of negative pi fourths. Cosine of negative pi fourths is, let's see, negative pi fourths puts us in the 4th quadrant. So cosine is positive. So this is 4 times root 2 over 2, which would give us 2 root 2. And then y is 4 times the sine of negative pi fourths. That's in the 4th quadrant. Sine is negative. Still root 2 over 2. So this is going to be the point negative 2 root 2. So that answer would be 2 root 2 comma negative 2 root 2. Okay. Going the other direction with this. Let's take a look at 14. So the tangent of theta equals 2 root 3 over 2, which is root 3 over 1. Where on the unit circle is your opposite over adjacent root 3? I believe that's pi thirds. So theta is pi thirds. And then let's get our r. So r squared equals 4x squared plus y squared. So 4 times 3, which is 12, plus 4 is 16. So it looks like r is 4. And our answer would be 4 comma pi thirds. Okay? Converting each from rectangular to polar, again, you're looking for y's to be r sine theta, x's to be r cosine theta. And anytime you have an x squared plus a y squared, you can replace it with an r squared. Over here, going from polar to rectangular, these are kind of tricky, and I'm not as worried about you doing them. If you want to play around with them, again, the answers are there, so I'm going to say don't worry about these either. What I really want you to be able to do, though, is graph this. So r equals 5, that's just the circle with radius 5. Am I coming around here on the right spot? Yes, there we go. R equals 6. R equals 7 cosine of theta. Plot some points. Get one complete revolution of it. 4 plus 3 sine theta. Again, I would love for you to just plot points and graph it. Same thing for 2 plus 2 sine theta. As we go through each one of these, this is what I need you to be able to do. I know there's a lot of them, but you have all the time in the world to get them done. I'm looking to see if we have petals. I'm going backwards. None of those have petals, so I'm keeping going here. Ooh, the r squared, here's our petals right here. This one's going to have 3. This one's going to have 4. Again, I'm looking at that number. Okay, and here's some more. Lots to do. and then here are the answers. Hopefully this is helpful. I'm sorry for that one that I couldn't quite seem how to get the numbers right. Please email me once you've finished and you have questions, and then we'll probably set up maybe for the two of you and to come in with me, and we will do some tutoring, and then we will do parametrics after that. Okay? Have a great summer. Talk to you soon.